All right, we're going to be looking at 8.5 Inequalities. Page 617 is where it begins. These are what the pages look like, so go ahead and open up your textbook pages so that we can begin taking some notes. The first thing we're going to do is work on our vocabulary startup. It says an inequality is a mathematical sentence that compares quantities. So we have a little graphic organizer here. You're going to fill in the definition, which, I mean, honestly, they just gave you, the symbols of an inequality, and an example and a non-example. So I'd like for you to fill those in, and then when you come back, I'll show you my answers. All right, so your definition, it really already gave it to you. It's a mathematical sentence that compares quantities. We have the greater than or equal to symbols, and then we also have the less than or equal to symbols. Some examples, and yours could be completely different. I just basically wanted to make sure my sentence was true. An example is 5 is greater than 2. Remember that the alligator eats the big number and poops out the little one. And then 4 is less than or equal to 16. It is in fact less than, so that is a true statement. The non-example here, I just put something like 5 is less than 1. That doesn't make any sense. The alligator eats the bigger number, poops out the little one. 5 is bigger. That's what the alligator should be doing. Okay? The real world link, it says compare the following using less than or greater than. So read through 1 through 5 and put your greater than or less than symbols in there. Make sure that the alligator is eating the bigger number. All right, the score after 2 goals is blank. The score after 3 goals, that's less than. The cost of to download 10 songs is blank. The cost of downloading 2 songs, greater than. The outside temperature in summer is blank. The outside temperature in winter, it's greater than. And the height of a first grader is blank. The height of a 6th grader, hopefully that's less than. And the time to eat lunch is blank. The time to brush your teeth. Well, I guess it depends, because you should be brushing your teeth in the morning and in the evening, so I don't know how this one could go. So you could say either one, honestly, and I would accept it, because the time to eat lunch is greater than the time to brush your teeth whenever you brush your teeth in the morning, and it's less than the time that you brush your teeth if you're brushing your teeth, or when you're brushing your teeth in the PM. So here are the inequality symbols and the words in the the examples they use. Just wanted to point out that just because there's an equal sign here doesn't mean it has to be equal. It's saying that it's less than or equal to. So sure, this could be 7 is less than or equal to 7 as well. And this could be 12 is greater than or equal to 12. And it would be true as well. Even though the less than and greater than wouldn't be true in these cases, the statement is saying, is it less than or equal to? Well, sure, it's equal to. And just like in these examples, it's less than or it's greater than. And so that's a possibility of an answer. So less than, greater than, less than or equal to, greater than or equal to. Inequalities can be solved by finding values of the variables that make the inequality true. All right, so now we're going to use our the same information, the same methods that we used when we did our one-step equations. We're going to do that with our one-step inequalities. So they're giving us, and this is how we started with our equations, was they were like, oh, let's try out these 3 numbers and see which one works. Remember we started that way? So we're going to do the same way with this example 1, where they're giving us a couple different values for f, and we're going to figure out which one will work in this situation. So first they say, okay, let's try 6. So they plug in 6 and they say, okay, 6 plus 2 is less than 9. That's a yes. And then when they tried f is 7, so we said, okay, 6 is a good one, but maybe it's not the only one. 7 we tried, and 7 plus 2 is 9. 9 is less than 9. That's not going to work. So we're not going to use our 7. So then we have f is 8. We say 8 plus 2 is 10. 10 is less than 9. That's not going to work either. So this is the only one that's going to work. So we can say that a solution for f could be 6, and that would work. Okay? It can be a lot of other numbers, by the way, because if you think about it, if you tried 4, think about this. If it was 4, we'd have 4 plus 2. 4 plus 2 is 6. Is 6 less than 9? Yes. So 4 could also work. There's a lot of numbers that could work. One of the numbers, in fact, would be 6, though. And that's what the question's asking. Of these numbers, which one is the solution for the inequality? And 6 would work. Of the numbers 8, 9, or 10, which is the solution of the inequality n minus 3 is greater than 6? Go ahead and solve this, and when you come back, we'll look over the answer. All right, so the answer for A is 10, because after I go through and plug each of them into the different solutions, 10 is the only one that gives me a solution that is true, that 7 is greater than 6. 5 was not greater than 6. 6 is not greater than 6, but 7 is greater than 6. And so when I plugged in 10, it worked. So it says determine solutions of an inequality. Since an inequality uses greater than or less than symbols, one variable inequalities have infinitely many solutions. Infinite many solutions. Just like I was talking about on the one of the last examples where I said, okay, it could have been this other number, it could have been another number. There's a lot of numbers out there that it could be. So that's an infinite many solutions. For example, an irrational number greater than 4 will make the inequality x is greater than 4 true. So if I chose 5, 6, 7, 8, 9, 10, 32, 45, I could just keep going higher and higher and higher into infinity. So example number 2 is the given value a solution of the inequality. So they're giving us a number. Just like they gave us 3 numbers before, they're giving us one number now. And so we're just going to plug it in. We've got x plus 3 is greater than 9. We plug in the 4, and we say 4 plus 3, that's going to be 7. Is 7 greater than 9? No, that does not work. So the answer is no. Is the given solution, is the given value a solution of the inequality? The answer is no. Number 3, 12 is less than or equal to 18 minus y, and then they're telling us y is 6. So we're just going to plug it in, bring on our equation. We're going to say 18 minus 6. 18 minus 6 is 12. And so is our statement 12 is less than or equal to 12 true? Yes, it is. So the answer is yes. And this is how we would show our work. So you're going to fill in for 4. 17 is greater than or equal to 11 plus x, where x equals 8. So we set up our equation. 17 is greater than or equal to 11 plus x. What are we going to put into our box right here? We're going to put our 8. So we're going to replace x with 8. Now what are we going to do? You should be saying, let's add. So we're going to add 11 plus 18, and that's 19. And now we're going to look at it, and we're going to say, okay, does this work? 17, is that greater than or equal to 19? They've already told us, nope, it's not going to work. And so since blank is not greater than or equal to blank, blank is not the solution. So since 19 is not greater than or equal to 17, 8 is not a solution. Because remember, this was the solution, not 19, but this was the number that they wanted us to, the value they wanted us to use to see if it's a solution. And it's not. You're going to do B, C, D, and E, and when you come back, I'll have the answers written out for you. All right, now check your answers and see if you agree. Check my check how I did my math and how I substituted my numbers. All right, so it says name 2 solutions of the inequality 12 is greater than 6 plus y. So there's a lot of possibilities out there. I'd like for you to think up of a value for y, 2 different values for y that would work with this inequality. So the way to figure this out is that we know that 6 plus y needs to be less than 12. This 12 is the big number. That's the one the alligator is eating. And so this is what it's pooping out is our 6 plus y. So I need 6 plus y to be less than 12. So it can't be 6 plus 6. So 6 won't work. But how about 6 plus 5? 6 plus 5 would be 11, and 12 is greater than 11, so 5 would work. You could choose 6 plus 4. 6 plus 4 is 10, and 10 is less than 12, so that would work. 3, 2, 1, 0. All right, so you could have picked any number between 0, 1, 2, 3, 4, and 5. 6 cannot be included in that. So number 5 example, Louisa works at a gift shop. She receives a bonus if she makes more than 20 balloon bouquets in a month. Which month did Louisa receive a bonus? Use the inequality B is less than 20, where B represents the number of balloon bouquets made each month, to solve. So she gets a bonus if she makes more than 20 balloon bouquets in a month. Which month did she receive the bonus? So we're looking for these numbers that are more than 20. Okay, so we're looking for greater than 20. So really it should be pretty simple. You just go through. 25, she is above 20, so that's a check. 12, she's not above 20. 18, not above 20. 32 is above 20. So she made a bonus in July, and she made a bonus in October. Okay? And that's all because we're looking to see which days she made more than 20. All right, that ends Chapter 8, Lesson 5, Inequalities. I'll see you in school.